Okay, today we're going to be looking at Chapter 4 topic, well, depending on the class you're in, but this is factored form of quadratic. For the regular class, this is Chapter 4 topic 3. I'm not sure what it is for the honors class. Let's take a look at the lesson here. Factored form. Basically, we are graphing in the third form, factored form. Factored form, unlike the other forms, factored form provides you with the x-intercepts. The factored form is y equals a times x minus p, x minus q, where p and q are the x-intercepts, sometimes called the roots, sometimes called the solutions. They got a lot of names. Now, not every quadratic is going to have x-intercepts, so not every quadratic can be written in this form. Let's see exactly how this is done. So if we know that p and q, so y is equal to a, x minus p, x minus q, if we know p and q are x-intercepts, then we simply have to identify p and q in the problem, and we'll know where our x-intercepts are. Okay, so p in this problem would have to be -1 in order for it to say x plus 1. We would have to subtract a -1 to get x plus 1. So one of our x-intercepts is -1, 0. Q, we would have to subtract a 3 in order to get x minus 3, so our other x-intercept is 3, 0. So our x-intercepts are going to be here, -1, 0, and 3, 0. Now, remember, anytime that we graph, we're trying to set up our table, and our table should have the vertex directly in the center. And every problem we do, we're looking for where that vertex is. And that's no different here. We're looking for where the vertex is. Well, we can figure out the x-coordinate of the vertex based on the fact that this graph should be symmetrical. Okay, the axis of symmetry should be in between these 2 points and the halfway point. Okay, so if we look directly in between these 2 points, we know our axis of symmetry should be at 1. Because the fact that this is symmetrical, the axis of symmetry should be directly in between these 2 x-intercepts. So 1 is going to be the x-coordinate of our vertex and our axis of symmetry. And then we can fill out our table. To the left of 1 is 0, to the left of that is -1, to the right of 1 is 2, and to the right of that is 3. Now we already know what we get when we plug in -1. We get 0. That's already a point that we know. And we already know that when we plug in 3, we get 0 as well. All right, so I just need to plug in a few other values to fill out my table. So I'll plug in 0. So I'm going to plug in 0 for x into this equation here, this one right here. I'm going to plug in 0 for x. So I got 0 plus 1 and 0 minus 3. Okay, so that's +1 times -3, which is just -3. So plugging in 0 gives me -3. Because of the symmetry, I also know that plugging in 2 would give me -3 as well. All right, I just need to plug in 1. So let me plug in 1. So I got 1 plus 1 and 1 minus 3. So that's going to be 2 and -2, which is -4. So plugging in 1 gives me -4. All right, so I've got all the points for my graph now. I can go ahead and graph this. -1, 0, 0, -3, 1, -4, 2, -3, 3, 0. And it makes a parabola just like always because it's a quadratic. So it's going to look, I should have used a different color, but it's going to look like this. It's going to be a quadratic. It opens up because of the positive out here. The vertex is going to be at 1, -4, which represents a minimum value, the minimum being -4. The axis of symmetry, we already determined that was at x equals 1. That's the equation for the axis of symmetry. The y-intercept, we would plug in 0. When we plug in 0, we get -3. So the y-intercept is at 0, -3. The domain refers to the x values. In this case, our x values are everything, all real numbers. And the range refers to our y values. Our y values are everything above -4. So it would be y values that are greater than or equal to -4. So we can see it's pretty much very similar to the way we graphed in other forms. The only difference is setting up our table finding the vertex using the x-intercepts instead of something else. All right, let's look at the second example. 2 times x plus 1 times x plus 3. This is in factored form. Factored form is a x minus p x minus q, where p and q are the x-intercepts. So I can identify my x-intercepts here. In order to get x plus 1, p would have to be -1, so -1, 0. And in order for x plus 3, q would have to be -3, so -3, 0. So that's going to be right here and right here. Now, I'm still using this information to help me set up my table, okay? Because my axis of symmetry, which is the x coordinate of my vertex, should be right in between those 2 points. Okay, so halfway in between these 2 points would be here at -2. So I know that the middle of my table, where the vertex is at -2. I can fill out my table from here. To the left is -3, to the left is -4, to the right is -1, to the right is 0. Now I already have some points, like -1, 0, I already have that one, and -3, 0, I already have that one. So I just need to figure out a couple more. So let me plug in -4 into this formula here, or this equation, right here. So y is equal to 2 times -4 plus 1 times -4 plus 3. So that's 2 times -3 and times -1. 2 times -3 is -6, times -1 is +6. So plugging in -4 gives me 6. And because of the symmetry, plugging in 0 would give me 6 as well. All right, let me plug in -2. So y is equal to 2 times -2 plus 1 times -2 plus 3. So -2 plus 1 is -1, -2 plus 3 is +1. So that's -2. So plugging in -2 gives me -2. Now I can graph this. So -4, 6, -3, 0, -2, -2, -1, 0, and 0, 6. My graph looks like this. You'll notice that it's very narrow, okay? And this 2 out front is what's actually causing this to be extremely narrow like this. This opens up. The vertex is at -2, -2. The vertex is a minimum point, the minimum being -2. The axis of symmetry is also at -2. The y-intercept, you would plug in 0, and if we plug in 0, we get 6. That's right here. Domain is all real numbers. And the range, y value is greater than or equal to -2. And that is our second example. All right, let's take a look at number 3, our last example here. Y is equal to -x plus 3 times x plus 3. So y is equal to a x minus p x minus q, where p and q are the x-intercepts. So our x-intercepts here, you'll notice, are exactly the same, -3, 0, and -3, 0. So we actually only have one x-intercept, and it's right here. Well, think about what this has to look like if we only have one x-intercept. If we only have one x-intercept, then that point must be the vertex. The only way for a quadratic to hit the x-axis once is if the x-intercept is the vertex. So we actually know the vertex is right here at the x-intercept, -3, 0. And then we can build our table around there, -4, -5, -2, -1, and I can plug in values to get my graph. So y is equal to -5 plus 3, -5 plus 3. So that's negative. You can think of that's negative outside as being a -1. So that's -1 times 2 times 2. Sorry, -2 and -2. -5 plus 3 is -2. -5 plus 3 is -2. So that's -4. So plugging in -5 gives us -4. Due to the symmetry, that would also be the case with plugging in -1. All right, let's plug in -4. So -4 plus 3, -4 plus 3. Remember, this can be thought of as a -1, so that's -1 times -1 times -1, which is -1. So plugging in -4 gives us -1, and due to the symmetry, that would also be the case with plugging in -2. So our graph looks like this: -5, -4, -4, -1, -3, 0, -2, -1, -1, -4, and you'll notice that our graph is upside down like this. You can tell that it was supposed to be upside down because of the negative sign in front of the problem. That negative sign is going to flip it over, which means it opens down, the vertex being -3, 0, which in this case is a maximum point because it's the top of the graph, the maximum being 0. It's as high up as it goes. The axis symmetry would be at x equals -3. That's the equation of the vertical line. The y-intercept, you would plug in 0, which actually I don't see it on my graph. So let me plug in 0 and see what I get. -0 plus 3, 0 plus 3. So -1 times 3 times 3. So -9. So plugging in 0 gives us -9. Our y-intercept is actually down here at -9. Our domain is all real numbers. And the range is y values less than or equal to 0. Everything below 0 here.